Hello, everybody. Welcome to this Design Challenge webinar. I'm just going to give us a few minutes for people to join the room, so just bear with us. We only have about 6 people in the room right now, so just give us a couple minutes. See you back here. Okay. Hope everyone can see that. Yep. Okay, I think just 2 more minutes and we'll begin. Hi, everybody, if you're just joining now. Hi, Matt. We can see you now. It's great.
Yeah, rough and ready here.
Great. Great to see you, Matt. Okay, if you're just joining now, we're just giving it a few more minutes until everyone can join. Numbers peaking up, so. If you're just joining now, everybody, we're giving it a little less than 1 minute left until we'll begin the webinar and get it going while people still join. Okay, let's go ahead and start. So good morning, good afternoon, or good evening, everyone, depending on where you are. We've got an international group today. Welcome to the Efficiency for Access Design Challenge webinar on the affordability of appliances. My name is Sean Davy. I am part of the Efficiency for Access Design Challenge team, and I'm the facilitator of this webinar. I'm joined today by my colleague Jackie Garcia. I'm sure you're all familiar with her throughout the Design Challenge. A bit of housekeeping before we begin. First, a reminder that this webinar is intended for participants of the Efficiency for Access Design Challenge, an initiative led by Efficiency for Access and supported by Engineers Without Borders UK. This webinar is recorded and the cameras and microphones of everyone, but the main speakers are disabled, just so you know. However, please feel free to ask questions throughout the webinar, and particularly during our Q&A session. If you do ask a question during the presentations, we'll pick them up at the end in the Q&A session. I would encourage you to do so because I'm excited to say we have gathered a great panel of speakers for the event today, and I'll introduce you to them very soon. First, a look at the agenda. So we'll go through our 4 guest speakers, and they'll all give presentations of around 10 minutes. And then we'll follow this up with a Q&A period where you can ask any questions you have to them. One of our speakers today, Joshua Milburn, is in Japan, so he recorded his section of the webinar. Any questions that you might have for him, you can say there for him in the chat, and I'll follow up in an email, and he'll get back to us following the webinar offline. And then finally, before we close, we'll have a webinar feedback survey. So we just want to hear your input on webinars, help us improve them in the future. Okay. So I just want to give you as much time for the Q&A as possible. So let's get through this. First off, we have Matt Carr from Agsol. Matt is a renewable energy technical and market access specialist. He has worked at the forefront of energy access throughout the Pacific, Asia, and Africa with solar startups, international power companies, multilateral donors, and NGOs prior to co-funding Agsol in 2016. Then we'll hear from Alex Clayton from M-KOPA. Alex Clayton is an M-KOPA commercial product manager. He's responsible for managing M-KOPA's portfolio of commercially available products and bringing new products to scale in M-KOPA's market through organic growth and strategic partnerships. Previously, he was a part of M-KOPA's research and development team, M-KOPA's labs, where he had led the development of a higher power system and grid appliances. Before M-KOPA, Alex worked with Global Giving to grow their crowdfunding platform in Australia in the technology practice of Addy Partners, an investment management firm in San Francisco. Joshua Milburn from Angaza will follow with his recording. At Angaza, Joshua builds open source technology, expanding energy access, including Nexus Key Code, the industry standard token protocol powering 2 million PayG devices worldwide. With the support of Efficiency for Access, his team released Nexus Channel Core, a hardware agnostic solution for device to device interoperability for even the most constrained devices. He will share how adapting existing industry standards to the specific needs of the industry provides a common language for device communication, while also enabling manufacturers to innovate faster, provide unique value-added features to end devices. Finally, we'll hear from Ilana Cohen from GSMA. Ilana Cohen is the Senior Market Engagement Director for the GSMA Mobile for Development Utilities Program. The program has played a key role in catalyzing the early pay-as-you-go energy sector and has supported the replication of this model to other sectors. For the nearly 8 years, Ilana has supported the development of partnerships between the mobile industry and utility service providers. This includes oversight of the program's innovation funding, which provides grants to test and scale innovative mobile-enabled utility service models and production of industry insights. Ilana holds an MSc in Water Science Policy and Management from Oxford University and a bachelor's degree in biology from Brandeis University. So, without further ado, please take it away, Matt. He's just told me that he has some connection issues, so bear with us if it takes a little bit of time to go. Can you hear us, Matt?
Yeah, thanks, Sean. It's a bit scratchy here. I've been switching between the two connections available to me, and neither seem particularly great. Are you hearing me okay?
Yeah, hearing you loud and clear.
Okay, cool. Okay, thanks. Hi, everyone. My name's Matt Carr. I'm the founder and CEO, or co-founder and CEO of Agsol, and we specialize in the manufacture of solar-powered agro-processing machines. Next slide, please, Sean. Okay, so this is just a founding statement here. That the majority of people that have or don't have access to electricity, most of them are smallholder farmers and depend on agriculture for their livelihoods. Next slide, please. So when we are talking about the productive machines, or at least solar productive machines that can serve the agriculture value chains, it's typically recognized that these three groupings of technologies present the greatest potential for impact and to catalyze this kind of second generation or second wave of energy access. So yeah, Agsol's focus is primarily on agro-processing, but we very much see our product as a tool that's kind of part of a bigger or broader toolkit with other appliances like refrigeration, like that can provide kind of broader, greater, more holistic solutions to people living in off-grid areas. Next slide, please. Thanks, Sean. So when you look at the demand for agro-processing, you know, where I'm based here in Kenya, and our market focus at this moment is in the East Africa region. Our primary focus is on cereals. The most important of them in this part of the world is maize. And the opportunities presently for off-grid people to process their maize to an edible product, because it does need processing before they can eat it, is either doing it manually or using 100-year-old technology, which is a diesel-powered mill. A couple of things that's worth. So when we look at that, it's a huge energy jump to go from manual processing to, you know, typically the smallest diesel-powered mills are 10 power. They're large. They're you know, they're the only solution available in off-grid areas. So, you know, we are targeting the gap between you know, manual processing and diesel mills, ultimately to decentralized and create a much more decentralized network of milling stations. Just a couple of stats there down the bottom of that slide. Milling is always done by, or the responsibility for milling is always done by women. You know, sometimes they outsource that to their children, but there's a huge hardship accessing milling technologies in off-grid areas. You know, in worst case scenarios, women are walking 5+ kilometers to get to the nearest mill. And it's a big, you know, there's a lot of money spent on processing grain. So, you know, just in a collection of East African countries, there's over $1 billion USD annually at milling stations, those typically being diesel mills. Next slide, please. So Agsol's been working on, you know, in this space for 4 or 5 years now, and, you know, we're at iteration 4 of our product range. And, you know, I suppose one that highlights the, you know, how complex this is to get the unit economics right for milling, and I'll come back to some of those challenges later in the presentation. But this is our current product that we're piloting in Kenya and Uganda present at the moment. This is version 1.0 of our new micro mill, and it's designed for processing grains, whether they be maize, sorghum, millet. It can also do dried tubers like cassava. It uses like a high-spec brushless DC motor in direct drive format, which is one primarily to reduce costs and reduce losses in power transmission. It does have a lithium-ion battery behind it. That's a kind of an essential piece for a mill, because you always need power to be kept up to the milling head. It's smart. What I mean by smart, there's a lot of custom that we've built our own kind of microprocessor that runs the mill. Another innovation in the mill is it incorporates an automatic feed control mechanism, and that's an industry first for any small mill of this variety. What that means is that the operator can be entirely unskilled and have no kind of mechanical, technical capabilities. All they need to do is ensure that the grains are clean, and they load the mill, and the mill, the automatic feed control system and the microprocessor takes care of everything else. We're interoperable. So presently, with the current version, we have that operates on a 48-volt system, but we have some small power conversion gear inside. So we can run 12-volt appliances or a range of 12-volt appliances off the system. And the IoT and PAYGO piece, that's a part of the product development and process. Next slide, please. So we started our field trial for the micromill about 5 months ago, And you know, these are the numbers that we were. Oh, it looks like there's a. Sorry, I think there's something not quite right with that second table. But these were the numbers that we were assuming that we would see from the pilot. So the mill has a production rate of about 30 kilograms per hour. We were assuming it would be running it for 4 hours a day. That would be producing, you know, 120 kilograms of flour with a daily gross income of $6. There's the numbers under the next kind of the customer business case highlights would be that, you know, the mill would be sold for $1,500 at a retail price. That's for the full system. And then with a on PAYGO financing, there'd be a 20% down payment, and which would then, and then over a 24-month financing period, that would require a $1.65 daily payback. So if we're seeing a daily gross income of $6, you know, the take home would be, you know, a little above $4, which we see as a reasonable kind of income for a small rural business. So there you see in the bottom, the reality has been different, and I'm just going to discuss through, you know, what the results of our pilot have been so far. You know, the challenges that we've experienced, and you know what that means for us as a technology developer and provider going forward. So the first primary challenge that we've seen is that with the field trials, and you know, admittedly, it's from a fairly small data set. There's 10 mills in the field presently. We're only seeing a daily utilization rate of 1.5 hours or less per day, compared to what we were expecting, which was something more like 4 hours. So the mill can in fact run for 6 hours a day. So the utilization rate that we're seeing is less than 25% of what the mill can do, what the power system can do. And that has, you know, the kind of knock-on effects for the unit economics. Meanwhile, what we're so, you know, one idea to counter that would be then to make a smaller mill, or a smaller mill, lower power consumption, a smaller solar system. But, you know, meanwhile, what our customers are saying to us is that they want a mill that's faster, not slower. So a faster mill means a bigger power system, which is in fact more cost, and they're also asking for a cheaper mill. So, you know, it kind of sets up a bit of a catch-22 dynamic there. One of the other challenges around milling, and particularly with solar milling, is that, you know, with business as usual with diesel mills, there's quite distinct milling peak kind of demands during the day. And the biggest peak that you see with a diesel mill is later in the day, kind of from 4 p.m. onwards, and that's when 75% of the milling is done. So as you can imagine, with a solar mill, that doesn't lend itself particularly well. So there's this aspect of kind of behavior change that needs to happen around milling, or at least solar milling. The other kind of big takeaway from the field trial is that the typical consumer financing model that you see applied in solar space is typically around, you know, a 20% down payment of the product cost. You know, and I think for productive use appliances, and particularly for a solar milling appliance, that needs to be reevaluated, and that initial upfront payment needs to be increased. And that's kind of what we're also hearing is being echoed from some of our partners who have quite a bit of experience in the product space, particularly around pumps.
Matt, I think we've lost you for a second. Can you hear us? I think we'll just pause for one moment until Matt can rejoin. Hear us again. Can you hear us at all, Matt? Okay. Sorry, everyone. Seem to have some technical problems. This always happens when we have these online meetings. Matt, are you there? I see you've come back online with your mic. Okay, might give it one more minute and then we might have to move on to Alex's presentation. Matt, you hear us? Okay, seems he's gone offline again. So maybe we can pick it up again towards the end, but for now, I think we'll move on to Alex's presentation. That's all right. But thanks for Matt. Matt, sorry, Alex. Matt was representing our productive use and rapid return on investment portion of the affordability webinar, and Alex will now take us into the pagey section.
Great, thanks very much. Hopefully I'll be able to stay connected the whole time. Let's see. Great. So hi everyone. So I'm here from M-KOPA, which is a predominantly a solar company, but doing pay-as-you-go products across mostly East Africa. So we're in Kenya, Tanzania, Uganda, and Nigeria. And my presentation is going to be focused a little bit more in the abstract on sort of design principles and what we consider to be, or what I would consider to be important to bear in mind when designing pay-as-you-go solutions, and specifically pay-as-you-go appliances. So if we go to the next slide, that'd be great, thanks. Great, so this is definitely not an exhaustive overview, but I just wanted to highlight sort of when you're sort of thinking about designing a pay-as-you-go system, and specifically a sort of a pay-as-you-go appliance, I think it's very tempting, and even sort of in M-KOPA's history, it's been very tempting to really focus on the product. So thinking about, okay, well, you know, do we want a 24-inch TV, and should it be HD, should it be smart, should it have a DVD port, all of these sorts of things. But I think that the key thing that I think is worth highlighting, and really the point that I want to get across today, is that really, in order to be successful when designing for pay-as-you-go, it's essential to design for the system. And so by the system, I mean the sort of the complete product life cycle, and sort of the full range of things that you'll need to consider. So on the sort of beginning of that, of course, is thinking about the product. So you can either design in-house, or now there's a pretty thriving industry of just suppliers, so you can source quality products that people will need, value, and use every day. And so we just heard from Matt that, of course, you know, productive use is something that's really growing within the sector, and so maybe every day becomes every week or every few days for people who are buying, for example, a water pump or a mill or whatever it might be, and that might be enough. But certainly for the core pay-as-you-go solar industry, the majority of those use cases are things that customers will use every day. And so it's worth bearing in mind here that not everyone is, not all products are necessarily compatible for this pay-as-you-go model. So, for example, like an easy one to think about is washing machines. You know, washing machines is a laundromat. That really is a pay-as-you-go product, because you go, you put your money in, and the washer works. But that's not something necessarily that people, number one, use every day, and number two, that people would necessarily want to have in their house and would prioritize as sort of a use of their finances. So the actual selection of product is of course important, as it is with any other business model, but there is a barrier with pay-as-you-go, making sure that the product is compatible specifically for the pay-as-you-go model, and something that people will want to pay for on a recurring basis. Secondly, then you need to think about connectivity. So there are a lot of different ways that you can do this, but the key thing is that you need to be able to talk to your device. That's the essence of pay-as-you-go. You need to be able to lock it and unlock it, and then beyond that, you can decide to add additional features. So, for example, you might want to do performance monitoring, so you can understand, you know, if there are any issues with your device, or being able to do some predictive analytics on the battery. But you do need to design with connectivity in mind. So you can decide how you want to do it, but you can't forget about it. Thirdly, then is on payments. So of course, another aspect of this is that you need to be able to handle payments. So there are, again, a lot of different approaches to this, but you need to be able to process payments, so collect money from your customers. And then you really, the bit that's behind the, sort of under the hood of all of this, is you also need to have a pretty sophisticated understanding of loan management, and how you can allocate credits in exchange for the cash that you've received for your customers. So that again needs to be something that is considered from the beginning when you're designing your product. Fourthly, then is thinking about sales. So this sounds obvious, and it's true, of course, of any product development process, but you really need to understand how you plan on getting it to customers. So this should be right at the beginning of your design process. Then understanding, okay, do you want to develop your own sales force? That's something that M-KOPA has done in Kenya. We have just over 4,000 salespeople in Kenya, but that's a very labor-intensive and is quite slow to scale. So that's something that you do need to bear in mind. And on the more practical side is if you're developing a product that's enormous. We a couple of years ago launched a fridge. That's very, very different to how you would manage the sales of a big product than you would selling something small like a phone. So you need to design for that as well. And finally, then servicing. So the essence of the pay-as-you-go model is that the customer wakes up every day and decides that they want to pay for your product. So it's essential when designing for pay-as-you-go that you also design with servicing in mind. So you need to think about, will you have a sales force in the field? A maintenance team in the field? Will you be able to have a call center? All of these different things that ultimately will impact how you design your product and also how you think about servicing it. So I think the overarching point that I'm trying to make here is that it has to be a systems view, and it has to consider the entirety of the value chain, because ultimately they are all related. So if we go to the next slide, please. Great. So really the important thing, or one of the important things then, is how this all manifests, which is around unit economics. And so this, I think, is one of the bits that potentially is easy to overlook in pay-as-you-go, but that is to say that the product only accounts for a small portion of the actual cost to the customer, or the price to the customer. And so, as I've said here, it's a complex and quite an expensive business model. And so you need to be able to, as you're designing these appliances and as you're thinking about business models, you need to be able to sort of price these in from the beginning. And the nature, of course, of pay-as-you-go is that if you have, for example, a 2-year payment plan for a customer, or even a 1-year payment plan for a customer, is that if you get these assumptions wrong, then ultimately this comes back to bite you in a year's time or 2 years' time, when you don't get your margin. And so that really is something that I would really encourage as you're thinking about designing pay-as-you-go appliances, is that a lot of time needs to be focused on the business model and understanding the full impact of the unit economics. So customer research, when you're doing it, willingness to pay is notoriously difficult. It's specifically very difficult for something that is that has hundreds or even thousands of micropayments. But it's really important to be able to get your willingness to pay research right. And the first part of that is making sure that you've got the right price that you actually will be able to position to your customers. And so what does this mean then for the actual products itself? So when you're designing your products and thinking about appliances and thinking about weighing up things like efficiency versus sort of simple technologies and things that you can buy off the shelf, ultimately that means that for every dollar of cost that you put into the product, that is compounded over time by the amount of financing that will be required in order to be able to make it pay as you go. And then also things like, the bigger the product is, the more cost it'll take in your distribution channels and through your sales process. So when you're, as you're going through this process, it's really important to think about, okay, well, what are the trade-offs? And bearing in mind that the trade-offs occur throughout the value chain. And so you sort of really need to be able to have this whole system-wide view. And finally, as I've said at the bottom here, the key thing as well is that because the customer is paying every day, the product, you need to optimize for reliability and quality so that on day 375, that the customer is just as excited about paying for the product as they are on day 5. And so really the exciting thing about pay-as-you-go is that it's a very pure form of business, which is that it is beholden upon the supplier to be able to create something that the customer is genuinely happy with, because the customer makes a decision every day that the product is worth paying for. So if we go to the next slide, please. So in summary then, or sort of taking a more specific view at each of these different steps, I would just highlight these are sort of the key areas that I would encourage you all to consider as you're thinking about designing these solutions. So of course, on the product side, the number one thing you need to think about is what problem you're solving and who you're solving it for. That's the same with any products that you might want to develop. But it's critical, of course, in this example. So for example, if you're designing for an urban user in somewhere like Nairobi, then that's a very, very different sort of supply scenario, and sort of demand side context is extremely different from what you might expect if you're designing for someone in a much more rural or sort of lower income category. And so you need to get that right from the beginning and be very, very clear on your identifying and understanding your customer. I think then, as I've highlighted as well, the suitability for pay-as-you-go. Not all products are really designed for pay-as-you-go, and something that's really interesting that Matt touched upon briefly is that actually also there are different types of pay-as-you-go as well. So there are different ways of approaching it. But you should also be clear on how you want to do it, and whether that's something that's a daily payment, whether it's a weekly payment, or even just a payment in installments. So there are lots of different ways that you can manage that. The dichotomy between an open and closed system, this is a really interesting one that is a sort of debate across the sector, and I think both approaches are worthwhile. The definition of open and closed is that, so M-KOPA actually has closed systems, and that is that we control all of the appliances and accessories within our ecosystem. So you can't plug in a laptop or a lamp or whatever it might be to our battery systems. You can only use our own appliances. So that's something else that you'll need to bear in mind. And then finally on this product section, just really thinking about end of life. I think this is becoming a more prominent discussion within the sector. And I do think that it's something that should really be considered from the beginning when designing new appliances. So really thinking about, are we adding unnecessary complexity? Is there a way that we can use, for example, a natural refrigerant rather than a chemical that's harmful, and various different considerations like that. I won't go into all of the different considerations here, but I'm sure that that they will be made available after. But I would just really encourage you all to bear in mind that designing appliances and thinking about designing systems really should be considered from a holistic point of view. And I think especially for sort of the perspective of a student rather than necessarily someone working within the industry, that can be challenging. But the good news is that the industry, I think, increasingly is becoming more and more open, and the value chain is also getting broken up a little bit. So you've got more and more companies who for example, are focusing on, we'll help you do the distribution, or we'll manage your loan book for you, or even on the product side, more and more people are allowing people to source their products indirectly. So I'd really encourage you to when you're thinking about these systems, to go out and do that research, and maybe even speak to those companies. But yeah, that's sort of the main point that I want to drive home today is that designing for pay-as-you-go really needs to be designing from end to end as a pay-as-you-go solution, and I hope that some of these points have been sort of a helpful point of reference. So thank you.
Thanks, Alex. Thank you. That's great, and it provides a lot of practical design elements for our participants. Yeah, and Alex is right. All of this material we shared with you after the webinar. I'll send an email to all of you with the slides. I see that Matt is now back online. Matt, would you want to say some closing remarks about your presentation?
Sure, happy to. I actually don't know where I left off earlier, so I might have been talking to myself for a while. But look, just to wrap up, some of the I think I kind of had covered like some of the challenges that we'd seen with our field trial, and which weren't as which were kind of a little bit unforeseen. I suppose the thing here is that in this space, in particular productive use space, milling is by far the least developed or mature product, and no one's cracked it yet. No one's got a product or a business model that fits. So we are at this the leading edge of trying to work this out. And I echo everything I just heard Alex mention about really having your customer in mind and knowing the market, and being able to iterate and respond to challenges as they kind of present themselves. And it would be fabulous for us to have the the yellow brick road kind of leading us to product and business model success. But the reality is that with all the market research that might be at your disposal, and the hypotheses that you bring to product development from that market research, that there is a point in the product development life cycle where those hypotheses need to be tested, and and as we have found, they don't always stack up. So for us, we're now exploring our kind of V2 product design. There's some technical considerations to that. It's making it more productive, making it in terms of faster, in terms of improved efficiency, because again, efficiency is this key factor around reducing the other kind of components of the solar system that we have no control over the pricing of those things. They're just commodities. The cost reduction in the mill, offering it in different power supply formats. So at the moment, we've only really tested it in solar mill format for this particular customer segment of village entrepreneur. But once we have this core, the core module of the machine, which is the milling piece, it's quite easy to offer it in some put some power conversion gear in front of it, so we can offer it as an AC format for mini grids, or for contexts where there's the power tariff is relatively high, or offer it in AC with battery for weak grid. And yeah, there's I won't kind of delve into all the details about where we're exploring improvements on the product side. Also, what that means for exploring and testing different customer segments, and exploring and testing and working with different distribution partners. And finally, the financing model. I think, as Alex was saying, this is the pay-go piece, the consumer financing thing. It is very tricky, and I think different rules apply to some of these productive appliances. And where we are in an exploratory phase to try to work out where excuse me, where these intersecting lines of kind of product, market, customer segment, and whatever all kind of intersect. But yeah, we still feel as confident as ever that a solution does exist, and that it has very, very immense scale for impact in the off-grid sector, given the high demand for milling services in off-grid areas. So I'll leave it there. Thanks. Thanks, Sean. Thanks, Jackie.
Thanks, Matt. Thanks. Okay, great. And it's great to see these different perspectives presented here today, for you all to take away for your own designs. Okay. I'm going to be presenting Joshua's section, which was recorded, but just to note that it seems like we'll be running pretty close to the end of time by the end presentations are done. So please write your questions in the chat in the meantime that you might have, and we can pick them up offline over email with the panelists, and that'll give us time to collect them before it's over. Okay, I'm going to go ahead and share Joshua's presentation now. Can everyone see this?
Hello and welcome to this webinar on device interoperability and how it applies to affordable appliances in this industry moving forward. I'm Josh, work at Angaza, primarily on connected embedded devices and securing the communications between those devices, as well as between those devices.
Can everyone see this? I just wanted to check before I kept going. Alex,
Yes.
I see that you turned on. Yep. Okay.
Between those devices and the cloud. I'll be talking today about something we've been working on with industry partners called Nexus Channel Core and how it relates to this entire topic. But first, a little bit of background. Today, we have mostly these standalone pay-as-you-go devices, which I think you're familiar with. You know, we buy a device, it has typically a keypad on it. User pays for an amount of money and they get credit. They type it into the device and it works. And everything from small solar home systems to handheld lanterns to larger lighting systems, it's a pretty common model. You'll see it across the industry. So I won't get too into it other than to say there's some challenges today as we start to see larger and more complex systems in homes. For example, a user might buy a solar home system on a pay-as-you-go basis, and 6 months or a year later, buy a separate pay-as-you-go TV meant to be standalone. Now they're receiving 2 key codes, one for the TV and one for the solar home system to enable it. And this scales with the number of appliances that are meant to be standalone that they buy. It's an issue for the user and usability. It's an issue for support, because if the user has a mistake entering a key code, how does support disambiguate user entry versus a product problem? It's a lot harder because they don't know, okay, well, was it entered in the right device? Was it entered in that device in the order of this other key code before or after it? It's not totally clear, and it's just a lot more troubleshooting. Besides pay-as-you-go, there's energy prioritization issues. Let's say a user has a TV and a fridge, and they would like to know, if I use my TV tonight for 4 hours, will my fridge be able to run until the morning? They can answer it heuristically based on past experience, but there's not really a great way to do that in a standard fashion today. And devices from different manufacturers can't exactly communicate that information easily. So let's say someone is a great manufacturer at solar home systems and associated accessories, but maybe they want to partner with someone who's really great at making refrigerators. Now there's a lot of upfront R&D effort to make all these devices communicate because they just are operating on different electrical and physical link layers. So we're going to see larger interconnected systems in the future, larger refrigeration systems, solar water pumps, agricultural systems, and typically, I mean, these all need power in some way. So whether we're talking about solar, battery, intermittent grid, potentially we're all sharing from some power source at some point. And it would be great if they could communicate, in addition to the state of the battery and making decisions based on that, their own state. I mean, failure states, control states, remotely updating the settings on these devices from another device. Is there a way to do it in a way that you can understand how it impacts the whole ecosystem of devices that are connected there? And beyond just communicating in general, how do you do it securely? Let's say we're talking about refrigeration for medical cold chain. You certainly wouldn't want someone unauthorized to be able to just turn off the fridge and destroy a bunch of vaccines. So that's a separate concern, but still a concern here as well. And so, a lot of these applications go beyond pay-as-you-go, and it would be great if we had a way to solve this that wasn't just reinventing something that's already been done elsewhere in the IoT universe, and it wasn't only specific to pay-as-you-go. And so turns out there is a standard, and it was standardized in 2018. It's from a group called the Open Connectivity Foundation. It's used today by large manufacturers like LG, Samsung, Intel, typically in smart consumer electronics, and typically a lot larger scale. We're talking, manufacturers who have very large global distribution networks, but not typically in the markets of interest. And so one of the limitations there is that these are typically designed for microcontrollers and control hardware in these devices that is a lot more expensive than what we see in most off-grid devices. And so that presents a problem because we'd love to use the standard, but we would not love to increase the BOM cost to do it. I mean, it's basically a non-starter in some cases. And without getting too much into the details here, class 0, which is shown here, is not supported explicitly from the standard, is a large number of devices in the market. use class 0 microcontrollers. So what can we take from this? What is useful? Well, we can take the application layer interoperability piece. Open Connectivity Foundation's standard, OCF, has a lot of pieces, but one of the most salient pieces for our discussion here is this notion that devices should be able to communicate about some specific application. So they shouldn't need to worry so much about how they're connected electrically, how bytes are sent on the wire, but more about, can I talk about some property of the device, like a battery or a fault status or something else at a very high level, and design interesting applications around it, not do I have to get down to the bits for every single new device to integrate. And so that's when I say application layer, that's kind of what we're talking about here, and allowing manufacturers to interoperate at that layer, independent of how they're connected below that, whether it's Bluetooth or some proprietary wired link, and then security can be layered on top of that. So again, why do we care about application layer? We don't want it to be dependent on these lower transport layers. So let's say you build some standard that's built around Bluetooth. Well, that's great, as long as devices use the current version of Bluetooth. Let's say we just pick the current PLE version. Well, 5 years from now, are we going to be able to source those chips? Are we going to be able to use the same standard connectivity? Is Bluetooth even going to be affordable for some of the devices in the market, or does it exclude a lot of them? So, there are a lot of transport layer decisions which could really lock you into a standard that might not be relevant in 10 years. And we're interested in building a standard that applications can use and rely on for many years, independent of how devices are interconnected. So obviously pay-as-you-go state is one application, but I mean, you might have standard ways to pull devices and get telemetry data back. You might want to share limited battery resources. They're basically any application. It's not really specific to one use case or another. The idea is if you can have an application layer language that all these devices talk, you can develop any application you want. Just speak that language and expose the resources you care about. So let's get into what resources are a little more. That's the core piece we're taking out of this OCF standard, which is the notion that I can define something like a battery or a TV or inductive stovetop state, and I can define properties on that resource. So I can say a battery has voltage, a battery has capacity, a battery always has these properties. Maybe it has some other optional properties as well, like other cell health status. But if everyone agrees that a battery at least must report capacity and, let's say, voltage, as an example, then any device that implements that battery resource can be pulled by another device that says, do you have a battery resource? And if so, oh great, tell me the percentage of capacity you have left, and I'll make a decision based on that. So it allows you to write application logic without having to go into the weeds every single time. But it doesn't prevent you from having more specific proprietary use cases. So what I described there was a battery that had certain mandatory properties like capacity and voltage, but you might define some other specific ones that are value adds that only work, with a little additional integration work. Again, we're all speaking the same language to talk to these devices though, so it's still less work than customizing an integration with a very specific link layer all the way from the bottom up. So we have some example resources out right now you can go check out. There's some that are in development. And I think I want to take a look specifically here at this battery resource just to get a better idea of what these kind of look like. It's intended to be very clear to a web developer or someone who's not deep in the embedded hardware. And this isn't something that we came up with in-house. This is essentially drawn straight from the OCF standard, and how you represent this. You have some kind of endpoint like /battery, and you have a certain set of parameters that are just defined. You say batteries always have CP and MV in this example, millivolts in capacity. And if you pull the battery resource, you can get that information. In this case, you can actually set something related to the low battery state of charge if you're authorized as well by posting back to it. So even though under the hood, there's no web servers, there's no, HTTP running on these devices, from an application developer's perspective, it looks like that's what's happening. And so it makes it easy for the application developers without making the hardware and software constraints on the device, without violating those low-cost constraints. You don't have to put like an embedded Linux processor in here to get this kind of behavior. So we're just going to breeze through this, but the pieces we're talking about here are mainly in blue, how devices talk to each other. There's an entire other set of work here around security and how that interplays with platforms. We're not going to talk about that today, but I just want to emphasize that it's important to have a standard way for devices to talk to each other about what they can do and about what the state of the system is, without relying on specific integrations between every single device and every single manufacturer. And that's really what Nexus Channel Core is about. So, currently we have a release with some examples on GitHub of battery resources implemented, and you can run that on a microcontroller. We've been granted resources from Efficiency for Access to bring this out as an industry standard, and we're actively working with Solaris, who's developed a really innovative lower link layer from defining how things should be wired electrically up to how the bytes are sent on the wire. So devices can connect using that link layer and then run Nexus Channel Core on top of it for these higher level application examples. So that's all I have to talk about right here. Feel free to email me any questions, and thanks for listening to this presentation.
Okay, thanks to Josh. He's working on some really exciting technology at Angaza. If any of you had any difficulty with the sound, please let me know. We'll share it in the final recording, and we'll make sure it's in there so you can see it back, etc. Next, we'll be hearing from Ilana. Just so everyone knows, again, we're running out of time, so I think we won't have time for a Q&A session, but you're open to send your questions in or send them over email, and we can answer them offline. Okay, so if you don't mind taking it away, go ahead, Ilana.
Great, thanks. Can you hear me okay?
Yeah, loud and clear.
Great, and apologies, there's some technical difficulties getting my webcam cooperating with the operating software here on my computer, so we'll go without the webcam. Thanks for the opportunity. I won't take too long, so I will get us done in time. My name is Ilana, and I work at the GSMA in our Mobile for Development Utilities program. If you go to the next slide, I'll just explain a little bit about who GSMA is and our program. So the GSMA is the Association for the Mobile Industry. So that means we represent the interests of mobile operators worldwide. We're actually made up of a number of separate entities within the GSMA, and one of those is the GSMA Mobile for Development Foundation, where we drive innovation in digital technology to reduce inequalities on our world. And specifically, I work on our Mobile for Development Utilities program, where we're concerned with the billions of people who lack access to essential utility services like energy, water, and sanitation. And so we are looking at ways that digital technologies can enable affordable and reliable and sustainable utility services, particularly focused on low-income populations and those in urban and peri-urban areas. So that mention of urban is a bit of a shift, and we've, for the last 8 years, done a lot of work both in rural and urban context. So if you go to we'll go to the next slide, but also to mention that our program is funded by the UK Foreign Commonwealth and Development Office. So if we go to the next slide, and sorry, these are a little bit small here, I'm seeing. Apologies for that. In terms of how we do that work, one of the main activities in the middle there is de-risking and catalyzing innovative utility services. And we've been doing this for the last 8 years through an innovation fund where we've given grants for organizations to trial and scale these models. A lot of those grants have been aimed at understanding, really catalyzing a lot of what you've heard about today, some of the early pay-as-you-go solar models. M-KOPA was an early grantee of our program back in 2013 when these models were first kicking off, and there was more need to explore the relationship between these models and mobile operators. And so out of those grants, what we do is we share insights, and we do also additional research to really share with the broader industry how these solutions can work, and best practices. And then we do a lot of partnership facilitation and convening to ultimately achieve impact at scale. So if we go to the next slide, what I wanted to firstly talk about, I think it's pretty clear from the presentations that we've heard about around the synergies between off-grid energy and mobile operators. So we don't need to go into too much detail here, but for the pay-as-you-go solar companies or appliance manufacturers, we've heard about how it's essential for payments, for remote monitoring, also for communication with staff and with clients. And let's not forget the basic need to really call customers and check on them. It's a huge huge need. I think the emerging area still is on the big data analytics. I think there's been a lot of excitement around this one for a long time. First, for the reason of wanting to do credit scoring on customers. That has, I think, not been seen in practice as much as we would have liked due to the complications around security concerns, and I think really understanding what is the value for a mobile operator given the risks. What's the value of that information, of sharing that information, which I think is sort of still a question mark for them. So it's an emerging area. I think the area that we're seeing more big data analytics work around now is on using mobile data to predict locations for these solutions. So if we go to the next slide, we have at GSMA done some work though to quantify the value that mobile operators get from off-grid solar. This is a study done in 5 countries looking at the usage of mobile money and mobile services and the overall revenue that brings to an operator when somebody gets pay-as-you-go solar, and then comparing that to customers without pay-as-you-go solar. And I won't go through these all in depth, but the trend is clear that a pay-as-you-go solar customer is valuable for a mobile operator, and it does increase the revenue for them. So that is a really important relationship to understand, because mobile operators are highly commercial entities, and they're not really, I think they're interested in social impact, but it has to come with commercial impact as well. So if we go to the next slide, I think my main points are really here that we can discuss. Just to talk through what I think are some of the things to consider around affordability when it comes to the mobile angle, and some of these have been discussed a little bit. You know, we heard from M-KOPA about the cost of distribution and sales, and very early on in this industry, there was a lot of hope that mobile operator agent networks could be used to quickly achieve scale for sales, and I don't think that that hasn't really proven the case. M-KOPA changed their model away from that for the most part, though there's still, I would say, a strong branding relationship with Safaricom in Kenya at least. But there's a blog up just today about that relationship. Mobile money fee structures vary across markets. This is something really important to understand. We have a toolkit that helps you think through, in part, the cost of applying mobile money. So there's a choice between having the solar appliance provider pay for the cost of the transactions, or the end user. I see I'm really running short on time here, so I might just have to run through these quite quickly. I think another thing here is the mobile data costs. We heard a little about this already. There's a lot of design considerations here. We have a toolkit that's a little bit around this IoT journey to help point out some of the key points for thinking about costs. I guess starting with, I think, keypad versus a GSM system, right? You don't have to necessarily use monitoring. It's a very popular choice where there's networks and where you're going to use that information, but I wouldn't say it's a necessity, and it's really important to think about the actual needs that you have, especially when launching a product, because of the way it increases the cost. We heard a lot from M-KOPA about really understanding your product's market fit based on willingness to pay. I think that's really important, and that's sort of the second to last bullet point there about the cost of the loan versus the product cost and getting the right fit there. The last point is an emerging area, but we think there's a potential role of digital tools where we see a lot of interest in government and donor financing through things like end user subsidies, where we have some blogs on this topic, and results-based financing. I think if you can go to the next slide, I will wrap up. Just to say that there's obviously, we started with a lot of pay-as-you-go solar home systems, but there's been quite an evolution. I think the exciting thing here is that is not only that we're talking about energy appliances, but there's a whole world of now pay-as-you-go water solutions and some sanitation solutions. So all very exciting, and we'll share the deck with everyone, and I've just highlighted some useful resources for your follow-up reading. So sorry to rush a bit, but thank you all, and happy to get in touch with any questions you might have.
Okay, thank you very much for that, Ilana, and sorry about the time crunch at the end. And sorry to everyone for any technical difficulties we encountered today, but we'll be sharing the recording and the slide deck with you today, and my colleague Jackie will be putting the email that you can send your questions to into the chat, and you can send all your questions there, and we'll pick them up after the webinar offline. Finally, I'd like to thank all of our panelists today for coming out and speaking. It was really informative, and I think all of you can take some really practical design elements into your projects. Thank you, and you'll be presented with a 1-minute survey at the end of this webinar. If you could just fill that out before you leave. Thank you, and have a nice day.
Thanks very much.